Hello, my name is Kirk Hovell, and this is a video presentation of a sonar system that I built for MECH 5302 instrumentation techniques. Now, I have built on a previous project that I did last year. The video to that one is in the description. The previous sonar that I built had two microphones that I bought online, and it did simple range finding. This time I decided to build my own microphone. You can see here out of a Pringles can, and just replace one of the bought microphones with my homemade one. So the homemade microphone consists of a microphone, Pringles can, which collects the sound, an amplifier back here which amplifies the sound and reduces some noise, and then the computer which processes the signal. So I won't go through a full description on how the sonar system works. I'll focus just on the microphone I built, and I'll do a quick demo at the end. So firstly, this microphone is a empty tube of Pringles where the sound travels in this open end of the can, and it actually vibrates the little thin metal foil at the other end of the can. To measure this vibration, I attached a magnet with some sticky tack to the end of the can. You may be able to see it there. And then I made a coil of wire and suspended it over the magnet so that as the magnet is vibrating, it's vibrating within this coil. The coil is suspended over the magnet by attaching it to the cover of the Pringles can and standing that off from the end so it does not vibrate with the sound. The moving magnet within the coil generates a very small voltage, which is then sent over to this instrumentation amplifier that I built, where we're using 3 op amps, a bunch of resistors, a battery pack to power it, and this potentiometer to adjust the gain. The output of the instrumentation amplifier is then sent through this cable to the microphone jack on my computer. So the microphone does not perform very well, but it does actually work. So I'll do a quick little demonstration of how it works. I recommend you turn your sound up quite a bit because it's pretty quiet. So what I'm going to do is just command the microphone to record. I'm going to yell something into the microphone, and then the computer is going to play back what it heard through the speaker here. So I'll just hold the phone up to the speaker so you can hopefully hear it. Here we go.
Hello.
Okay, I will try that one more time. Here we go.
Hello.
So hopefully you heard that. There really isn't very much dynamic range. It's just a very noisy signal. But you can make out that I am saying hello. The good thing is that the data processing technique that I outlined in my previous video is good enough to detect what it has to out of that noisy signal. So now I'll do a quick demonstration showing the sonar part of this in action. So you're going to start hearing some chirps. These are coming from the microphone, or sorry, the speaker, traveling out, getting picked up by this microphone, traveling towards the target, bouncing off, and being picked up by this microphone. The turn this down a bit. The distance to the target is then calculated and shown on the screen on the left, or here. the lowest value is 0 meters and the highest is 0.8 meters. Let's put this back on the side. So you can see that right now it's around 0.1 meters to the target. And if I just move the target closer or farther away, you can see that the blue line on the screen gets bigger. And as I move it closer, you can see that it does get smaller. And if I take the book away, it should get quite big because the signal is going all the way to this wall and bouncing back. So this has been just a quick video showing this homemade microphone and that it does actually work. Thank you very much for watching.